What is biometrics? Biometrics is the identification of people for authentication purposes by examining their physical traits or characteristics. Bio for life and metrics for measure. All identity features are universal and can be quantified. Elements such as height, weight, build, gender, hair and eye color, retinas and irises, fingerprints, ears, noses, skin color, race, DNA and age are a few of the more commonly known categories. When you visually recognize a person, you are using the process of biometrics. Biometrics does not exclusively refer to automated computer recognition. Before anything can be automated, it exists in human capabilities first. Current technology is attempting to automate what people measure and recognize, but automation is at the beginning stages of programming. At best, it is able to give a list of possible candidates for further evaluation by a human researcher. Automated recognition originates with an input device, such as a scanner. Mugshots and fingerprint cards are two of the best-known biometric physical records, having been in use in the United States for approximately 200 years. Some biometric categories lack permanence. People can dye or cut their hair, wear lenses to disguise their eye color, and utilize makeup or accessories to alter their features. Facial hair for men can be highly appearance altering. Natural aging changes how we appear, since height may be slightly reduced over time due to spinal compression and stoop. Ears are one of the most measurable, unique, and unchanging human features, which is why it is the focus tool for our investigations. So just who is Ed Chiarini Jr.? Ed's full resume is available on wellaware1.com. He is a veteran, an independent journalist, a researcher, and an inventor with a patent for hydrogen fuel cell technologies. He is a contributing author, artist, and designer for books and a film on the JFK assassination. Ed is the owner-creator of Well Aware One videos, photo comparisons, and often makes guest appearances on the radio. He lives in Dallas, Texas, and has developed the process of extracting and refining gold and precious metals from scrap circuit boards, such as the ones in your cell phones. Dallas plus Gold plus Bug is a moniker he chose as a trademark and designed for his work and internet presence. Introduction. Whether you are new to ear biometrics, want a refresher, or are explaining it to someone else, this is a guide to the basic analysis of ear and biometric features and the work of Ed Chiarini. Ears are like two large fingerprints on the sides of the head. The lobes may change over time, but the rest of the ear stays consistent throughout a person's lifetime unless there is some injury or surgical intervention. At about the age of 60, the ears will begin to show slight signs of aging. They may start to droop a bit as the cartilage begins to soften. It is dependent on health and genetics and moves only a fraction, but may be noticeable to some analysts who have a trained eye. Ear analysis is unobtrusive and does not require permission or cooperation from anyone. With practice and patience, it is a learned skill. How can a person start to understand how it is performed? You can start with a picture of your own ear or that of a family member right now. Discover your own ears. Take a side photograph of both your left and right ears and compare them. You will see they are nearly identical but for discrete, very minor differences. Compare those pictures with the diagram on the following slide so you can become familiar with the terminology. Find pictures of your ears when you were younger. For beginners, find the pictures that are as close to the same camera angles as possible. Compare the current pictures of today with those from past years. For digital photographs, place them on your computer and size them proportionately to help you study them. A large high-definition computer monitor is especially helpful. Notice the shape and form of each curve of the ear, the helix, the trachea, and other areas. Trace each transition your ear makes, its shape and how it connects. As people age, their lobes stretch, and piercings or heavy earrings can exacerbate the effects of the passing years and gravity. Notice how the other areas of the ear have not changed over time. Take a moment to review this short video on lens distortions, light exposures, and angles at the following link. Finally, using a picture of a close family member, such as a parent or sibling, compare those pictures so you can see the genetic markers shared between family members.